So far we've looked at all the 6 different polymers that are the most common polymers that you'll see in packages and materials around you. And here's a summary of the page with the chemical formula for the monomers and polymers and their common uses. Next, I'd like to show you the difference between natural polymer and synthetic polymers and how to identify them. So first, let's look at cotton. Now, when cotton is made from cellulose, it's basically the same fiber that's used to make paper, and its origin is wood. When cotton burns, what would you expect it to smell like? Well, it smells like paper. And under a microscope, what you'll see is curled up. It looks like curled up ribbons. So this is kind of just a hand depiction of it, and here is the actual micrograph under a microscope what cotton looks like. Now let's look at wool. Wool is made of proteins. It's essentially the same as the material, the polymer that's used to make your hair and your nails. And as you might know, it comes from sheep. So when you burn wool, what would you expect it to smell like? Well, it smells like your hair burning. So, and if you've ever used a curling iron on your hair and maybe heated it up too much, that smell that you get, that's kind of like the same smell that you'll get if you burn wool. And under a microscope, what you see is ridges. And this is the actual micrograph of wool. And so what you see is just partitions and ridges, because it kind of, the way that wool grows, it grows from the inside out, and it's a lot like skin in some ways, because it'll have sort of these scaly partitions on its surface. Now let's compare these natural polymers to synthetic polymers or plastics. Under a microscope, these polymers that are man-made look very smooth. So for example, this is the actual micrograph of polyester. Let's compare that to the way wool looks and the way cotton looks. Sort of messy, and each fiber looks different, whereas fibers will look very consistent. Each fiber will look almost identical to the next fiber. And when you burn it, it smells like, well, what it is, which is a chemical. So it has a very chemically smell. And it's not going to smell like anything that you smell in nature. So that's the way to tell these 3 different types of fibers apart. Now this is a summary of what each of the different plastics that we've discussed will look like and smell like when put under a flame. So this is something for you to look at and consider. This is not something that you should try at home, because many of these plastics create a toxic smoke, and to burn them properly you really need to put them under a hood so that any smoke that comes out of it is away from you. So this is not something you should try at home. If you do try it in a laboratory, make sure that you have an approved hood where you're burning these various plastics. Now, some of the things to note here: PVC is the only one that does not stay lit when you put a flame under it. So in other words, you've got to keep the flame on it in order for it to continue burning. Otherwise, it will self-extinguish. That is different than the other polymers, because once you put these other polymers, it's kind of like a candle. If you light them, they'll continue to glow, and they'll continue to burn because they emit energy. Now, both HDPE, high-density polyethylene, and low-density polyethylene, they smell like candle when they're burned because their chemical structure is very similar to a candle. PET, on the other hand, creates a light smoke, and it burns very slowly. It has sort of a yellow flame. Polystyrene has a very dense black smoke, and this is also a very toxic smoke. So something that you should definitely not inhale. Same thing with PVC. Very toxic. Do not inhale it. And the one thing to note about PVC is that if you burn it, you'll see green spurts, and that green actually comes from the chlorine atom and molecules that are within part of the structure of PVC. And polypropylene will have a sweet, woody odor. So that odor is a little bit different than the others. So that's how you tell them apart with the burn test.